students, now we are going to complete examples given in practice set 1.1. Each and every example is very important. If you have understood these 5 examples, then you can easily understand the proof of basic proportionality theorem. Now when you are going to solve examples, first of all, read the given example carefully. Now I am reading it. The first example from practice set 1.1. Base of a triangle is 9 and height is 5. Base of another triangle is 10 and height is 6. Find the ratio of areas of these triangles. Now first of all, we are going to write the given things. Here, suppose I have considered the base of first triangle as B1. B1 is equal to 9. Units are not given, don't write it. Height of the first triangle is H1, that is equal to 5. And base of another triangle is 10. Therefore, B2 is equal to 10 and height of another triangle is 6. Now what is asked? They have asked find the ratio of areas of these triangles. Now I can write the ratio of areas of the triangles. We have learned the first property. By this property, we can write the ratio as B1 into H1 upon B2 into H2. Now substitute the given values. B1 is 9, H1 is 5, B2 is 10 and H2 is 6. Now here, since division of these two terms are given, don't multiply the two terms. Do the simplification rough, that 5 2s are 10 and here also 3 2s are 6 and 3 3s are 9 and therefore your final answer is equal to 3:4 and therefore the ratio of areas of these two triangles is equals to 3:4. This is your final answer. Now suppose students have forgot that we have eliminated 1/2 from the formula of finding out the areas of triangle. Then they will write here 1/2. But when you write here 1/2, the examiner knows that you have not studied the first property from your textbook. And that's why be careful that our property is only the ratio of product of corresponding bases and heights. Now we are going to consider the second example from this practice set. This example is included in SSC board examination. Many times the same figure, same digits are given in SSC board question paper. It is always asked for 1 mark. All these smaller examples are included for 1 marks or for 2 marks. Now the figure is two right angle triangles are given. When you are going to solve the examples in your notebook, draw the figure with the proper shape which is given in your textbook. This is the first right angle triangle given and this one is the second right angle triangle given. Now observe the figure. First triangle is triangle A, B and C. Since angle B is 90 degree, this is a right angle triangle. Second one is triangle A, D and B. Here angle A is of 90 degree. Now in given, they have given that BC is perpendicular to AB and AD is perpendicular to AB. Also they have given two values. Now I am going to write the given things. BC is perpendicular to AB is the first given thing. Again, AD is perpendicular to AB. Now, if you observe this figure, then we can see that here in both the triangles, the segment AB is common. Segment AB is common, and therefore I can write that the two triangles are having common base. But since the given triangles are right angle triangles, if I look the triangle as triangle ABC and triangle BAD, then this segment AB is the height of both the triangles. That means since the given two triangles are right angle triangles, AB is common base. If we consider AB as height, it is also equal height, and therefore to write the asked question, I can write it as area of triangle ABC is to area of triangle ADB is equal to BC upon AD. Now, while writing the reason for this step, I can write in both the ways that triangles having common base, or if I write triangles having equal heights, then also it is correct. Now I am going to substitute the values. Value of BC is given as 4 and value of AD is given at 8. 4 2s are 8, and therefore my final answer that area of triangle ABC is to area of triangle ADB is equal to 1:2. Write the final answer carefully and write your answer always inside the bracket. This example is included, I have already cleared that this example is included many times in SSC board examination. Now we are going to complete the third example from practice set 1.1. When you are going to complete these examples in your notebook, draw figure of each and every example. You are going to study this entire mathematics too with the help of the figures, and therefore don't ask that we should draw the figure or not, and therefore always we are drawing the figure to solve the examples. Now here one obtuse angle triangle is given. This is the main figure, and they have mentioned the height of the triangle in two different ways. That is, first of all, they have given a perpendicular from vertex P. The triangle is P, Q and R, and segment PS is perpendicular on base QR, as well as they have given the perpendicular from vertex Q on base PR, and this is segment QT. Now read the given example. Segment PS is perpendicular to RT. Segment PS is perpendicular to segment RQ. Segment QT is perpendicular to segment PR. Now what thing you are going to find out? Here the length of RQ is given as 6. Length of PS is given as also 6, and the length PR, the entire length PR is given as 12, and you are going to find out QT. Now here you are well known about the first property. Since I am having two different heights of the same triangle, I can write the formula in two different ways. First of all, I can take area of triangle PQR, also again area of triangle PQR. Now for the first time, I am going to consider PR as the base. Therefore, the answer is base PR. When I have considered base PR, QT is the height. And when I am going to consider base QR, at that time PS is the height. Now, since both the triangles are one and the same, the ratio of areas is 1:1. That is equal to 12 into QT. QR is given as 6 and PS is again 6. Now cross multiply. I will get here 12 into QT is equal to 6 into 6. Now therefore my next step is QT is equal to 6 into 6 divided by 12, and therefore simplifying this, 6 2s are 12, again 2 3s are 6, and therefore QT is equal to 3 units. This is my final answer. Now we have completed third example from practice set 1.1. Now I am going to take also fourth example. Since the concept given in fourth example, we need to prove basic proportionality theorem. If you have understood these examples, complete these examples in your notebook, write carefully and write the reasons for each and every step. Now I am going to take the last and the fourth example. Complete the fifth one as homework in your notebook. I am going to take the example number 4. Now the example is based on the concept of two parallel lines. What do you know about two parallel lines? By the definition of parallel lines, the perpendicular distance between the two parallel lines is always constant. Now they have given two triangles in between two parallel lines. Also they have given that the base of both the triangle is one and the same. This base is constant and these two triangles are given. Now observe the figure. Now here, first triangle is A, B and C. Second one is B, D and C. Suppose I want to determine the height of both the triangles. First of all, I consider triangle ABC. To determine height of this triangle, I can draw perpendicular from vertex A. Suppose this is the point P. And suppose I want to determine here also the perpendicular distance from point D. Then it should be a point Q. It is not necessary to draw this second perpendicular, but I am going to show you that suppose I can consider it, then this is the segment DQ. Now by the formula, by the property that the perpendicular distance between the two parallel lines is always constant, AP and DQ, both the heights are one and the same. Now they have given that AD is parallel to BC, since both the lines are parallel to each other. Also they have given that AP is perpendicular to BC. Write those given things. AP perpendicular to BC. Also AD parallel to BC. And they have given that find out area of triangle ABC is to area of triangle BC and D. Now observe the two triangles. First one is A, B and C, having BC as the base. Second one is BDC or BCD, Here base BC is also common, and therefore these two triangles are having common base, but and therefore the ratio of their areas is equal to ratio of their corresponding heights. But we know that since the given lines are parallel to each other, the perpendicular distance between the two lines is always equal, and therefore AP and DQ are also having the same length, and therefore the ratio is equal to 1:1. Since the answer, you are going to write it like this: area of triangle ABC is to area of triangle BCD is equal to 1:1. When you are going to write the ratio as 1, that means the next condition, by cross multiplying, we will get that both the triangles are of equal area.